Hi guys, welcome back. Today's presentation is on energy systems and their connection to exercise. And once again, we did cover this at level 2, but we're looking to build on that understanding and take it up to a higher level. So exactly what we're going to be looking at is understanding the energy system and how it relates to exercise. But in particular, we want to be able to identify the contribution of energy according to duration of exercise / activity being performed, the type of exercise or the activity being performed, or the intensity of the exercise being performed. And 6.2, we want to identify the byproducts of the free energy systems and their significance in muscle fatigue. So first of all, we want to look at a few of these variables. So when we say variables, we mean these changing factors, and these different factors will affect which energy system we use in the body to create energy for that particular movement. So if we have a look through the slide, we can see something like the first bullet point says percentages of maximum heart rate or 1 rep max. So if we're pushing our 1 rep max, our absolute 1 rep max, going as hard as we can go, we'll be using a different energy system to if we were just lifting maybe 30 or 40% of our 1 rep max. Same thing with heart rate, if I'm on the treadmill and I'm walking and I class myself as being reasonably fit, I can probably walk steadily for a long time. If we start upping the speed and I'm going up to like 80-90% of my maximum heart rate, once again, that's going to mean that I'm using a different energy system because of the intensity that I'm working at. And as well as intensity, we also have duration. So the number of seconds, minutes or hours that we spend on an exercise. A good example would be something like doing a long distance bike ride or a long distance run. When we first start off and it's all very easy, that's absolutely fine. But once we've been going for 2, 3, 4 hours, we're going to start using a different energy system. And also, we've got the type of movement. So if we're doing a very small movement with maybe a single muscle, that's going to use a different energy system compared to doing something like a squat, which is using lots and lots of different muscles. And as we go through the presentation, we'll try and identify which movements and which intensities and which types of exercise will kick in and will make us use different energy systems in the body. We also need to understand the fibre types, the muscle fibre types, which we should already know quite a lot about, but different muscle fibre types will use predominantly different energy systems. We have the type 1 fibres, which use the aerobic energy system. So the type 1 fibres, just to refresh you, are the ones that are for the long distance, continuous activity stuff like long distance runs, long distance cycles, those types of continuous activity. They're using the type 1 fibres. We then have the type 2A, which are the ones that flit a little bit in between the type 1 and the type 2B, if you remember from looking back at that presentation. And type 2A fibres can use the aerobic or anaerobic lactic energy systems depending on intensity and training history. So once again, depends on how they've been used in the past. If you're doing a lot of activity that uses the lactate system, then they're going to be able to use the lactate system more readily and more freely. If you're not, if you're doing the opposite to that, if you're doing a lot more explosive type work using the phosphocreatine system, then that's the system that they're going to be tapping into a little bit more. And brings us on quite nicely to the type 2B fibres, because these fibres are the ones that use the phosphocreatine energy system, and they can also use the anaerobic lactic energy system during very intense exercise. But the type 2B fibres are those really explosive ones, the ones with the poor blood supply, work really fast, really effectively, but then die away and can't sustain that activity for a longer period of time. So those are your type 2B muscle fibres. So big thing to take away, Type 1 are using the aerobic system. Type 2A can use the aerobic or anaerobic. It depends on our training history and what we've done in the past. Type 2B, they're going to be using phosphocreatine and potentially a little bit of anaerobic lactic as well, but it depends on how hard you're training for that one there. So, let's bring this up. Let's have a look at this ATP, alright? And ATP is essentially, to give it its correct name, is adenosine triphosphate. So, adenosine in the middle is the one molecule that we have here, and then going around the outside we have 3 phosphate. Okay, so triphosphate, adenosine, triphosphate. So adenosine, tri meaning 3, so adenosine and 3 phosphate. So when we require energy in the body, what happens is this molecule, this adenosine triphosphate, gives up one of the phosphate molecules in order to create energy, and that's how we make our energy in the human body. So we go from adenosine triphosphate, we give up one molecule, and then we have adenosine diphosphate. So in case you didn't know, di means 2, tri means 3. So it goes from adenosine triphosphate to adenosine diphosphate. And that no matter which energy system we're using, which we're going to look at in a minute, they're all about creating ATP and making more of that ATP or adenosine triphosphate, the same thing, making more ATP available to the body. So, there is only a very limited amount of ATP within the muscles. It lasts up to 3 seconds, and once it's used, it has to be replaced, alright? And the way we can replace it is we can use creatine phosphate in the phosphocreatine energy system, or we can use glucose or glycogen from the aerobic or anaerobic lactic energy system. So that there are our 3 energy systems that are all trying to create more ATP dependent on the demands of the activity. And we're going to go through, I'm going to have a look and break down each of the energy systems in more detail. Those are the 3 on there just for you to take a look at. And the first one we're going to look at is the creatine phosphate system, okay? And what the creatine phosphate system does is, first of all, it's important to know it's anaerobic, alright, which it says at the bottom here. So anaerobic means without oxygen. So this is an energy system that works without oxygen. And what it does is it takes creatine phosphate to remake ATP almost instantly, okay? However, creatine phosphate is in very, very limited supply. So we can use it, but we can only use it for a short amount of time. And once that time's gone, it's gone. And when I say a short amount of time, we're maybe looking sort of 2, 3, 4, maybe 5 seconds. That's all we've got in the creatine phosphate system, and it's for real quick, real explosive efforts. And after that, it's gone. But what we want to have a look at is how the creatine phosphate system works and how it helps us to create more ATP. So, looking at this, what we have here is ADP, alright? And this ADP molecule needs one more phosphate adding onto it to make ATP so that we can create energy. Just to recap that, because now it can be a little complex, alright? We have ADP, if we go back to this part of the presentation here, ADP is what we end up with once we've created some energy, and we need to add on another phosphate molecule to make it to ATP again, because we can only create energy from ATP. We can't make energy from ADP. So, back to here. What happens is, we have creatine phosphate floating around in very limited supply, as we said, and all we're doing is very, very simply taking the phosphate molecule from creatine phosphate, adding it to our ADP, and that's then going to mean that we can create ATP, and the remainder or the leftover product from that is one single creatine molecule without the phosphate added onto it. Alright, so that is essentially the process of how the creatine phosphate system works, and like we said, it is in very, very short supply, and it's for these sort of activities. As we said, 0 to 10 seconds absolute max, really explosive stuff. So 100-metre sprint, launching that javelin, shot put, golf and tennis swings, explosive type activities, weightlifting, the high jump where you have to give a real maximal effort. Those are the kind of things that we're going to be using the creatine phosphate system for. And again, real short term, real explosive stuff. After that, we have the lactate system. All right, the lactate system is normally the one that everyone hates because it really burns, and we'll talk about why and how that happens. So, lactate system is again anaerobic, so it's without oxygen. We don't need oxygen for this system to work. And what it does is it takes stored glycogen or glucose, takes that to the muscle cells to remake ATP. And this system kicks in when oxygen is not freely available. So we've used up all of the creatine phosphate system. There's no oxygen available because we're working really hard. So we have to use the lactate system. However, the lactate system produces a fatiguing by-effect called lactic acid, and that's what causes a burning sensation in your muscles. So, if you've ever done anything like a 400-metre run and gone out and run as fast as you can for 400 metres and you feel your legs really burning, that's lactic acid. If you've ever done something in the gym, like a giant set or a triple drop set, and your muscles are absolutely crying out and burning at the end of that set, that is lactic acid kicking in there, and that's the waste product of the lactic acid system. This is how the lactate system works. So we're taking glycogen from wherever it may be stored in the body, breaking it down into glucose and taking that glucose to the muscles. We use the glucose to create more ATP, and then the waste products that we have that big burn, and we also have lactic acid, which we need to flush out from our system. But that in essence is the lactate system, and it's important to note, it relies on taking glycogen and glucose to the muscles in order to recreate that ATP. Type of activities, stuff like 400-metre run, 100-metre swim, 200-metre swim, hurdles, anything really where we're looking at 1 to 3 minutes of real effort and going as hard as we can in that period of time. That's going to be using the lactate system. And the last system we want to look at is the aerobic system, and this is the system that we use for longer distance type activities, or activities that are going to be for a longer duration but at a lower or more moderate intensity. So best examples to give are, like we said earlier, long distance cycle, or going for sort of a long distance run or walk. That's going to be using the aerobic system, and the aerobic system is all about the breakdown of carbohydrate and fat with oxygen, alright, in order to create more energy. And the waste products in this system are carbon dioxide, because, as we all know, when we breathe, we take in oxygen, we give out carbon dioxide as a waste product. And if we want to measure how well our aerobic system is working, we have something called VO2 max, and VO2 max essentially is the maximum capacity that your lungs can work at, and that's the way that we measure essentially how fit someone is. So in sort of pre-season, you might see footballers doing a VO2 max test. You might see other athletes doing it, sort of endurance-based athletes, again, cyclists, long-distance runners, people who have to cover long distances at low to moderate intensities. VO2 max is a good test to be doing with them. And the one other word that I want to pick up on here is something called mitochondria. And essentially, what mitochondria are, they are the tiny little structures that you find in cells, and their job really is to look after the chemical reaction that releases energy from glucose. That's what happens inside the mitochondria, and obviously that's a real essential process for us to be alive and to be walking around. We need to have those mitochondria functioning, and sort of the tissues or the organs in the body that need a lot of energy, they'll have lots of mitochondria. So places like the liver, places like skeletal muscles that function a lot, they'll have lots of mitochondria. Places that are not so active and don't need quite so much energy will have less mitochondria. And here's what happens. Essentially, we take to the mitochondria, which are those little sort of organisms inside our cells. We take to them, we take oxygen, fatty acids and glucose. Mitochondria then converts that into CO2, which is our waste product, H2O, which is another waste product, but also ATP. And that really is how the aerobic system works. Important to know, the three things that we have going in are oxygen, fatty acids and glucose. So when we say fatty acids and glucose, that could be stored fats from our body. It could be stored carbohydrate or glucose, and that's why you'll see before your long distance athletes, before they go and do an event, that's why they'll eat a lot of carbohydrates, because they need to have those carbs to keep this energy system going. If you run out of carbohydrate, then one of those important ingredients there is missing. You know, if you can't get any glucose into this system, then we can't create any more energy. And that's why you'll see sort of your long distance cyclists and things constantly eating on the ride. Every 20 minutes, half an hour, you'll be having gels and bars to keep more carbohydrate in the system. And that's why they do that. Example activities, as we've said, got all those long distance things there: swimming, running, cycling, 5 and 10 kilometre runs, again a long distance. You got your marathons, triathlons, hiking, anything really over a long distance at that low to moderate intensity is what we're looking at for the aerobic system. And what we've got here, we've got all of them side by side, so we can have a little bit of a comparison and check everyone's understanding. So we have the CP system first of all, the creatine phosphate system. It's anaerobic, alright? It doesn't use oxygen, and we use it very rapidly, and it's creating chemical energy. And the ATP there is very limited. There are no real waste products. There was creatine left over, if you remember, but we can recycle that in the body, and it lasts for about 10 seconds with those real intense efforts, 90 to 100% of your maximum, and the recovery there it's normally quite quick, but it's anywhere from 30 seconds to 5 minutes dependent on your level of fitness. And we're going to be using type 2B muscles. When we use the creatine phosphate system, we're using type 2B muscles, which are those big, powerful, fast twitch fibres. Lactate system, which is the one in the middle, again, it's anaerobic. It works without oxygen, and it can get energy into us quickly. So it says rapid there. We're using glycogen to create our energy, and it gives us limited ATP. So, you know, this system doesn't last forever. You can't keep going and going and going. It only goes for sort of 1 to 3 minutes of intense activity, and then it's done. It can't do any more. The waste product that it creates is lactic acid, which is a product that starts to burn in our muscles and means that we can't exercise as much. It works in efforts of around 60 to 95% of our maximum intensity, and it takes it can take 20 minutes to 2 hours to recover. You have to break down and get rid of all that lactic acid in your body. I'm sure you've all had times where you've maybe done something really difficult and got a bit of cramp, and then all right, now I'm going to go again. Gone to move, and then the cramp comes back again. That's because we've not gotten rid of all of that lactic acid out of our system. And anyone who's ever played football, or sometimes runners will get this as well. You may have times where if you play a game in the morning or in the afternoon and you think you're all fine, and then you'll be lying down on the sofa at night, and you'll go to move or get up from the sofa, and all of a sudden you'll have cramp in your calf or your hamstring, sometimes your quad. Again, that is because we haven't broken down all of that lactic acid. Finally, we have the aerobic system. This is the system that we use for those long distance efforts at low to moderate intensity. There's no fatiguing waste products. So there are waste products, but they're not ones that stop our performance. And the waste products, as we know, are carbon dioxide, which we breathe out, water, which we can sweat out and get rid of the body. So it doesn't necessarily stop us from continuing our exercise, but there are waste products there. Can use this system for a long duration, and we need to have glycogen and fat, so carbs and fats, to be able to fuel this system and make it work. And it works at, as we said, low to moderate intensities. In order to recover, we need to have time to eat and drink, because, as we said, if we run out of glycogen or carbohydrate, we need to get more into the body. And that system now is using type 1 and potentially type 2A fibres. So, I hope that's been a helpful one today. This is the last one on your A&P, so if you want to do some more revision, you can do. If you feel you're ready, have a go at the mock paper and be sure to let us know how you get on, because if you need some more help or some more nurturing, then we can do that. If you think that you're ready to go on and have a crack at the main exam, you can get that booked in and get you sorted out and get you on the way to completing your level 3 anatomy and physiology. Thanks for listening, and as always, if you need anything at all, please let us know. Speak to you all soon.